So let us begin by figuring out the question we want to solve today is what is the integral of secant of theta? And of course your calculus teachers told you that this integral is going to be a line absolute value of secant theta plus tangent theta. And they came up with some weird justification as to why this worked. But it worked, and there's nothing they can do about it. But I want to show you where they get this piece of the puzzle from. Where the secant of theta plus tangent theta comes from. It's not something that they came up with arbitrarily. So, to figure that out, I'm going to first do algebra for this problem. So I know, using the reciprocal identity, secant of theta is 1 over cosine of theta. From here I want to multiply by 1 for both sides. So multiply by 1, but what will that 1 be? It's easier to work with cosine when it's a given power. So we'll multiply by 5 by cosine. So secant of theta is going to be 1 over cosine of theta, which is the same thing as cosine theta over cosine squared. From here, we can use Pythagorean identity, which we know, of course, sine squared theta plus cosine squared of theta is 1. So we know cosine theta is 1 minus sine squared of theta. And so this replaces that. So this becomes cosine of theta over 1 minus sine squared of theta. From here, I take this mess and replace it for secant of theta in the function, in the integral. So now we go back to our integration. So the integral of secant of theta d theta becomes the integral of cosine theta over 1 minus cosine 1 minus sine squared of theta d theta. From here we do a substitution, which is relatively simple. We let u equal sine of theta. du is equal to cosine of theta d theta. d theta is equal to du divided by cosine of theta. And because I like to show all my work in this situation, cosine theta over 1 minus u squared times, of course, d theta, which is going to be du over cosine of theta. Cosine theta is cancelled. So we end up with a very simple integral of cosine of 1 minus 1 du. Here we have to use decomposition to simplify it again. So again, doing our algebra to the side, 1 over 1 minus u squared is a over 1 minus u plus b over 1 plus u. Multiplying by least common denominator, which is 1 plus u squared, which is 1 minus u squared, sorry. We end up with a 1 plus u plus, of course, 1 minus u is all equal to 1. So from here, go again, by letting u is equal to 1 and negative 1 respectively, we get 1 is equal to a times 1 plus 1 plus b 1 minus 1 2a is equal to 1, and then a is equal to 1/2. For u is equal to negative 1, we end up with 1 minus a, 1 plus minus 1 plus e minus 1 goes away. 2b is equal to 1, b is equal to 1/2 once again. So from there, after we've done the algebra to decompose it, we end up with something really simple. We end up with the integral of 1 minus 1 minus u squared is equal to 1/2 of 1 minus u. Minus u integral plus 1/2 1 plus u du. Factor out the 1/2 from the equation. We factor out the 1/2 from the side of the equation. Get 1/2 integral of 1 over 1 minus u plus 1 over 1 plus u. Du. Here, a very simple integration takes place. So this becomes 1/2 negative ln 1 minus u plus ln of 1 plus u plus c. You ask where the hell did the negative sign come from? The negative sign came from right there. So, rewriting it, we of course let u be sine of theta, so thusly sine of theta plus c, which of course we can rewrite this using laws of logarithms. Ln square root 1 plus sine theta over 1 minus sine of theta. Now, to simplify this ugliness, here, rid of the square root, I want to multiply both sides by 1 plus sine theta inside the square root, so we'll do that. And so once we've done that, this becomes ln square root of 1 plus squared over 1 minus sine squared of theta. 1 minus sine squared theta is of course cosine of theta. Cosine squared theta. So you end up with ln square root of 1 plus sine theta squared over cosine squared of theta. Using the property of square roots, this cancels that cancels that. So we end up with 1 plus sine of theta over cosine of theta. Therefore, if I split cosines, and that will get me ln of secant of theta plus tangent of theta plus c. So that's where the secant theta and tangent theta comes from. It's not something we just arbitrarily bullcrap out of thin air. Now, it just seems that way because they don't teach you this in the beginning sections, but that's okay. It's a lot easier to use secant theta plus tangent theta as your view than doing it by the decomposition method that I've shown you. But I just wanted to show you guys that this particular integral is not something they came up with out of thin air. They were not drinking when they did this, I promise. So maybe next time I'll show you a different problem. Alright, good luck. God bless.